Two and a Half Admins, episode 178. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, you haven't done a plug for Clara for a while, Alan, but here's one of your articles, OpenZFS Storage Best Practices and Use Cases, Part 1, Snapshots and Backups.
Yep. So this article talks about some of the best practices to apply when using ZFS and some of the use cases that it's best for and how to get the most out of it. And so we start with the basics on using snapshots and backups, and then we have future parts that get into more and more advanced use cases.
Right, well, link in the show notes as usual. Let's do some news then. Hard disk drives are next in line to become mostly enterprise hardware, as NVIDIA and AMD could be planning to focus on AI, leaving consumers as second-class citizens, according to TechRadar.
I would argue that they already are mostly enterprise hardware and have been for quite some time.
Yeah, although I don't know that's the point they're trying to make. The point they're saying is that it looks like NVIDIA and AMD may be planning to focus harder on AI. And, I don't think that they're going to stop selling video cards for gaming and so on. But I do see that if they have limited manufacturing capacity, they're going to devote more of it to the cards that sell for $60,000 than the cards that sell for $600.
Again, much like my earlier snarky comment that hard drives already are largely an enterprise technology, what this article is talking about, potentially happening with NVIDIA and AMD mostly focusing on, the big powerhouse, you can't even really call them GPUs anymore, AI coprocessors. That's really already a done deal. That's already a thing that they have done, especially NVIDIA. AMD is having to play catch up there, but NVIDIA has cared about, its enormous AI accelerators that don't even have graphics outputs on the back of them more than the consumer cards for years now, because they are a heck of a lot more profitable.
So you're telling me that the hobbyist market is totally insignificant compared with even the SME market for hard drives?
I really am. It's an also-ran. I mean, it's not like hard drive manufacturers want to stop picking that money up off the table where it lies. But in terms of just sheer volume, let alone profit margins, there's no question. Consumers can't pay as heavy a profit margin for drives enterprises can. And the consumer market used to be a heck of a lot bigger for rotating hard drives than it is right now. SSDs have utterly destroyed hard drives in the consumer market. Basically, for a normal consumer, the only time they're even thinking about a rotating hard drive is if they're that very, very special brand of consumer that wants to build a NAS. And at that point, you're not even really talking about what a hard drive manufacturer thinks of as a normal consumer. Now you've drilled all the way down into hobbyists.
What about people who've got a bunch of stuff that they want to back up onto a USB drive? I know you don't even consider those to be hard drives, but even the cast-offs from the proper hard drive manufacturers that end up in those enclosures, surely that must be something of a decent market.
That is a relatively decent market. That is actually the majority of the consumer hard drive market right now. And being that you are a filthy shucker yourself, when you open one of those up, what do you find in there? Is it a consumer hard drive typically?
No, it's like a white label.
Yeah. It's a white labeled enterprise drive because, again, that's what it makes the most sense to make. And so they shoehorn those things into the enclosures and sell them off, again, to pick up the remainder of what they can get from the market. I mean, really, we all know normal people, right? Normal consumers. And we all know some of them who do the best that they can, and they try to back up their Windows or their Mac stuff to a little USB hard drive enclosure like you're talking about. What percentage of normal people would you say actually buy the backup drive and try to use it?
A very small percent thinking about it.
Yeah, I would put it at maybe 10 or 15%, even among professionals. I'm not talking IT professionals, mind you, but just like white-collar folks who work around technology and have plenty of budget to work with and take things fairly seriously, I'd say 10 or 15%.
Yeah, I think most of them are probably using large flash drives. I mean, you can get a 128 gig flash drive dirt cheap these days.
Yeah, I'm glad you brought that up because that's the other serious nail in the coffin here for consumer use of hard drives is, yes, SSDs are still more expensive than hard drives per terabyte. But the difference has gone way, way, way down. They're not even twice as expensive typically anymore. And you can buy 4 and 8 terabyte SSDs without paying a premium per terabyte. They cost the same per terabyte as 1 terabyte, regular old, like everybody gets them every day SSDs do. It's just a matter of paying more money for more terabytes, and that's all there is to it. So in order to actually want to spend a little less money to get a much larger but incredibly slower drive that's like huge and bulky and has all these other potential drawbacks, you're way outside the wheelhouse of a normal person in 2024 AD. We're talking kind of preciously about the trailing edge of a trailing edge. Consumer PCs are already a dying breed. For those of us who work in the industry, think about how much harder it is to buy like all the parts to build a normal PC. Not a gaming PC, something that you'd give to your mom or your sister, much less, something that you would stock a small office with. It's gotten more and more difficult as what little remains of the individual piece-by-piece industry gets tailored more and more and more to little special gaming rigs. And honestly, even the market for the non-pre-built gaming rigs is dropping more and more. If they're getting general purpose computers at all, they're buying a big brand out of a box. And let's face it, most normal people aren't buying general purpose computers at all anyway. They're using phones and tablets.
Yeah, and so part of the concern here is that the hard drive manufacturers are going to focus more and more on only the ultra capacity stuff, and especially because that's also needed for AI. You need massive amounts of storage. Flash is still not really that competitive compared to giant hard drives, both on the amount of power it consumes and on the amount of storage space you get per dollar. And in particular, looking at even if you need huge amounts of storage, the bigger the drives are, the fewer you need, and you get more space in a smaller power envelope. Although hard drives being hard drives, you don't want to get the number of spindles too low or you don't get the same performance. What's interesting here is after years of promises and so on, Seagate is actually showing off their 30 terabyte Exos HAMR-based drives.
What does HAMR stand for again?
Heat-assisted magnetic recording. Basically uses a nanophotonic laser to heat up the grain of sand on the recording material to make it easier to change its magnetic flux. And basically this allows them to pack them closer together because the one you're not shooting the laser at won't flip as easy. And so when you're trying to change the value of a certain cell with not its neighbors, you heat up only the part you want to change.
Normally, you would increase the current of the coil, and you would thereby increase the magnetic force. But as you do that, you increase the risk that you're going to have bleed over, and you're going to influence the neighboring cells. So if you dial the reactivity up higher than what the coil can actually overcome normally, but then you overcome it for only the tiny little place where you want to by heating it up on a medium where the heated medium has it's easier to influence than the colder medium. I forget the actual proper technical term. Then yeah, Bob's your uncle. You can go ahead and write that one without worrying about messing up the ones next to it. Seagate has HAMR. Western Digital has been working on MAMR, which is more fun to say and is microwave assisted. And it's essentially the same thing from a slightly different angle on the hardware side.
Yeah, but so far Western Digital doesn't have MAMR ready to ship. So Seagate's 10 platters of 3 terabytes apiece, making a 30 terabyte drive, gives it at least a 6 terabyte advantage over the best thing Western Digital has on the market right now at 24 terabytes of CMR.
But this is not shipping yet. It's announced and will be shipping in this quarter, supposedly.
So they've shipped units to hyperscalers, which means cloud providers and Facebook type companies. So these are being used in production by some people, but they'll be available to everyone starting this quarter.
The way this works is some of the very largest enterprises have reciprocal agreements with the hard drive manufacturers, and they'll get the first units of these of any kind of new massive drive. These select customers will get trial units that they will put into production use, but there's a lot in the way of agreements there. There are NDAs. And so basically the largest customers are working directly with the hard drive manufacturers to put basically the last stages of QA on at a scale that's larger than what a hard drive manufacturer is going to want to tie up inside their own facilities. Once you get to the very last stages and you're pretty sure you've got everything nailed, it makes a lot more sense to say, hey, gigantic customer, how about we give you, a few thousand of these drives at a reduced cost, and, we kind of work back and forth to make sure all the issues are ironed out, rather than having to spin up a test facility that you're paying for with your own people and your own hardware with no revenue stream to do a similar scale test.
Do they get metrics and stuff back from the likes of Facebook then?
Whoever their select customers are, yes, they do. That's part of the agreement. That's why the first stage is always typically, I think, like 6 months to a year, of this kind of trial production. Like they'll announce that they're doing it to the select customers, and you're usually looking at about 6 months to a year after that before they start shipping out to enterprises in general. But they're still typically kind of hard to get hold of, at that next stage. And then 6 months or so after that, usually you hit general availability, and you'll start to see the new drive model, show up at resellers, Amazon, Newegg, what have you.
Okay, this episode is sponsored by Kolide. When you go through airport security, there's one line where the TSA agent checks your ID and another where a machine scans your bag. The same thing happens in enterprise security, but instead of passengers and luggage, it's end users and their devices. These days, most companies are pretty good at the first part of the equation, where they check user identity, but user devices can roll right through authentication without getting inspected at all. In fact, a huge percentage of companies allow unmanaged, untrusted devices to access their data. That means an employee can log in from a laptop that has its firewall turned off and hasn't been updated in 6 months. Or worse, that laptop might belong to a bad actor using employee credentials. Kolide finally solves the device trust problem. Kolide ensures that no device can log into your Okta-protected apps unless it passes your security checks. Plus, you can use Kolide on devices without MDM, like your Linux fleet, contractor devices, and every BYOD phone and laptop in your company. So support the show and go to kolide.com/25A to watch a demo and see how it works. That's KOLIDE.com/25A. Miscreants absolutely love using GitHub to sling malware. This is a piece on the Register that references a report from the Insikt group, and they talk about this idea of living off trusted sites. This is not a new problem, but it is still a problem nonetheless.
So the way most malware avoids being detected is by having different kind of loaders that are the thing that actually run on your computer, and then they go and get the malware from somewhere else, usually where it was living encrypted, so it couldn't be detected where it's hosted, and then download it and decrypt it and run the payload. And a lot of these types of malware have started using GitHub to do it, because most big corporations don't block GitHub because it turns out to be required in order to install certain software. And so since it's expected that computers inside that network might be connecting out to GitHub, it doesn't trigger alarms and it doesn't tend to be blocked, whereas a lot of other private hosting in other countries might be.
This is a lot like, back in the day, malware authors would use various free web hosting sites, places like AngelFire, Tripod, what have you. Because it just, it's a really easy, really cheap way to get your crap deployed to a platform that, again, depending on your target, the idea here is that you want to, blend in with relatively natural traffic. So deploying, your malware command and control stuff or, your distribution network on like an AngelFire or a Tripod back in the day, maybe not the best venue if your target was a corporation, but if you were just, trying to get as many people's relatively unprotected home computers as possible, that was great. Of course, these days, free web hosting is just not really so much a thing as it was in the 90s and the early 2000s. It's not really what people are doing. GitHub is great because, as mentioned already, an awful lot of really valuable targets are already expecting a lot of traffic back and forth. Now, the downside to hosting your malware at someplace like GitHub is now you're flirting with, unlike hosting at an AngelFire or a Tripod or what have you, you're flirting with detection by an active, engaged, and well-paid InfoSec team. So there are always trade-offs here. You may have to dance harder to keep away from the blue team at GitHub, but while you can do so, you may have an easier time getting past the blue team of your actual target.
Yeah, and most of the time, the malware that's actually being hosted on GitHub and so on is encrypted so that GitHub will just see binary data that doesn't match any virus signatures. And the loader that's actually running on the infected machine has the right keys to decrypt it. And so we'll pull down the encrypted payload, decrypt it, and then execute it. And this stops GitHub from being able to detect it. It stops the network monitoring at the victim from detecting it and so on. And so it can be an effective way to do it. And, this isn't specific to GitHub. The same thing's been done at SourceForge and Google Drive and Box.com and any place where you can upload files for other people to download them. What's interesting in the report is they have a breakdown of where on GitHub people are hosting it. And they found about 40% of it uses GitHub Raw, which is kind of their pastebin type thing, which is kind of interesting because I would have expected more of it to be binary, although maybe they're just base64 encoding it or something on top of the encryption. And then 35% of it or so is GitHub Objects, which is GitHub's types of storage specifically for bigger files. And then about 15% uses GitHub Pages, which is their static site hosting system. And so if you have some static files, that can work as well. And only about 6.7% is GitHub Code Load, which is normally like how you download a tarball of a release of something from GitHub. And that's, what your package manager probably is doing in the background, building the packages and so on for if you're trying to make it look like legitimate software.
Presumably, a lot of the reason for hosting these malware backends at GitHub rather than, more traditionally just in an open S3 bucket somewhere is that GitHub's a little cheaper and easier to just go ahead and, fire up a throwaway account, deploy your crap. It stays as long as it can and, gets to as many people as it can and goes away. It's a little harder to just open up a throwaway Amazon S3 account and create a bucket and put your stuff there. It requires more effort setting it up. It requires more in the way of potential breadcrumbs to, lead law enforcement back to you when things start to go bad. So GitHub starts looking pretty attractive.
Yeah, not having to pay for hosting increases the profitability of your malware empire.
Although I really think it's more about the ease of setup and the trackability or lack thereof than it is the actual money.
Mm-hmm.
When you're talking about a successful malware organization, the amount of actual cash it might take to pay for the bandwidth to deploy the malware, not really that big a deal. If they were able to actually operate legally and above board, then that's probably exactly what they would do for much the same reason that normal legal entities do, which it's a lot easier to just throw the money at the problem and make it go away. After all, you're making more money. It's a business. You have money. The problem here is that spending money leaves a trail, where just hacking or creating free accounts leaves much less of one.
Yeah, and it turns out this is being used for all kinds of malware, whether they're hosting a Google spreadsheet that's bait for a rat, or even PowerShell scripts on raw.githubusercontent.com. And this kind of living off trusted sites strategy is likely only going to get bigger and bigger, especially since it turns out GitHub is pretty censorship proof because it's so critical to the software infrastructure.
So is there anything we can do about this?
Well, I think the biggest thing that we can do is not fall into the trap of blindly trusting any particular traffic just because it comes to one particular publicly available site. It's easy to fall into the trap of thinking, oh, this came from GitHub, so it must be legit. That's where you put the legit stuff. But it's better from an InfoSec perspective to say, we don't know if something coming from GitHub is legit because that is a large publicly accessible site that is not in any way under my control. So you should be looking a little sideways at it if necessary. It also might not be a bad idea to diversify the code repositories that you use and that you expect to see. Right now, this is a GitHub problem. It's not, for example, a SourceHut problem. Now, that's not to say that the same thing won't or can't happen on other repositories like SourceHut as well. So the mitigation here is not, oh, well, I'll just not use GitHub, I'll use a different one. It's keep aware of all the alternatives out there and think of them all as possibilities, and don't get yourself locked into that idea of thinking code comes from GitHub and GitHub is where good code is.
Yeah, I think the other parts are when you see malicious stuff, make sure to report it. And it's kind of on the GitHub team to make sure to actually action those. But at the same time, to make sure that doesn't turn into an avenue for attacks on people reporting legitimate stuff as malware, so it gets taken down, creating a different kind of denial of service attack.
Now, another possibility for, what can you do given who our audience is, if you're even a larval form wannabe red team type and you think it sounds like it might be fun to go hunting for this stuff, there's nothing stopping you personally from going trawling through GitHub, trying to figure out if you can find a way to identify these things and report them when you find them. That would not only be a potentially useful thing for somebody who's thinking of getting into InfoSec to do. If you find some, it also ends up being something that you can put on a resume. And the way that you end up doing it, how you run it down and you report it and the interactions that you have, those are things that you can blog about and stories you can tell. And all of these are things that can absolutely advance a career.
Okay, this episode is sponsored by Automox. Want to be prepared for any shitstorm that may hit your desk during the workday? Check out the brand new Autonomous IT podcast. Listen in as a variety of experts in the IT operations space discuss the latest Patch Tuesday releases, mitigation tips, and custom automations to help with CVE remediations. Make new work friends. Listen now to the Autonomous IT podcast on Spotify, Apple, or wherever you get your podcasts. That's the Autonomous IT podcast. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And if you want to send in your questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Sebastian writes, I have an enthusiast setup like I imagine you guys do too. Consider a router with DNS filtering, mesh VPN, and the like. Also a combined storage and VM server with a number of applications, including monitoring, home automation, and a Git service that things like Ansible depend on. You get the idea without me listing every component. Many other applications depend on the small number of devices and services mentioned. Which of these services should run on the same device or separate devices, virtualized or on dedicated hardware, with or without failover device ready? I'm not looking for an HA cluster or a basement full of servers, but I would like to avoid situations like DNS is on a VM, DNS goes down if the VM host reboots.
I love this question. And we've already thrown out the idea of clusters and HA and all this kind of stuff because this is, it's a home lab setup, right? So what I would recommend here is the idea is you want to divide your services into baskets such that if you lose one service in a basket, all the other services in that basket aren't doing you much good anyway. And the way that usually boils down to is you want to have a hardware device that is your router, is standalone from your main server or what have you, and it should be able to run all the services that it needs to get all the devices in your home access to the internet. So we're talking DNS at a minimum, obviously, all the regular router stuff, NAT and, any port forwarding. You want it to be running your DHCP as well. Because again, the idea is if your main server dies, you don't want your internet access to die, and you don't want to have to reconfigure anything to make your internet access work. You want to be able to Google the things that you need to do to fix the thing that's broken, and you want your family to be able to, go browse YouTube and, visit Facebook or Twitter or Mastodon or whatever, and not be bugging you about when's the freaking internet going to come back. So that's one basket, all of your internet dependent stuff. Now, everything else, honestly, I would say you want to run in VMs or containers on one server. And then you also want a backup system that you can back up all of those VMs or containers from your production server off to your, call it a hot spare. This is the same topology that I've been using in small businesses for 20 years now. The one thing I will say, DNS can get a little complicated because you might very reasonably object and say, well, I've got a private local DNS zone and, I need I want to be able to keep using that. And if I've got that on the router, that doesn't really work for my thing, yada, yada, yada. So here's your answer on that one. On your router, you want to have it serving your DNS, but you want to configure a stub zone or a forwarder that says, for my locally managed domains only, instead of trying to answer those yourself, I want you to forward those queries down to my internal only DNS server, which is going to be one of those VMs or containers that sits on your main server. So now anytime you want to look up petershouse.lan, what happens is you go to your router and your router says, oh, petershouse.lan. I don't go out to the internet to resolve that. I go down here into the main server in the basement to resolve that, and everything just happens seamlessly and automatically. So now, if your main server goes down, all your internet access still works. The only thing that's broken is that private zone that doesn't do you any good anyway because your main server's down and none of that stuff's there. So what you do now is you bring up all this stuff on that backup machine that you had over there. Ideally, this should be easy if you're doing containers or VMs because you're basically just making them active on that machine while you deal with whatever's going on your production machine. And then once you're done, you can either leave it that way and just change the labels on which box is which, or you can replicate backwards from the backup to the production, shut down all the stuff on the backup, spin them back up on the production, and then you're back in service that way.
Yeah. Basically what Jim said, keep the host system, like the VM host, as dumb and bare bones as possible, right? Because if it depends on DNS that's going to be in one of those VMs, that's not going to work. But all the host is responsible for doing is letting you start all the VMs and replicating those VMs to the backup machine so that they can be run from there instead if it happens that things break. This way you only need 2 servers. You can have more and you can spread the stuff out and do all that, but all you need really is 2 machines and a router.
And you want to follow the same general concept. You divide things into buckets where if you lose any one thing in the bucket, the other things in that bucket weren't going to do you any good anyway. Therefore, when you lose that bucket, you've still basically only lost the things you lost if you'd lost any one thing in the bucket. That's the concept that you're shooting for here.
And the only other thing I would say is be careful your home lab doesn't become production. Right? If you have an enthusiast setup and you have a lab where you like to screw around with stuff, try to keep that separate from the media server that the rest of your family depends on and will yell at you if it doesn't work. I learned the hard way to try to keep the labby bits and the pseudo production bits separate because otherwise, every time you want to do something, it's like, oh, I can't upgrade my file server this weekend because somebody's watching a movie.
This is where I fire back a little bit and point out I've been talking about VMs and containers this whole time, and that's the reason. Because if you've separated all your workloads into VMs and containers, then you can reboot just that VM without affecting another VM on the same machine. So you can patch them independently, reboot them independently, whatever you need to do.
I'm going to take the machine down and put more RAM in it, though.
Well, how often are you doing that?
RAM, not very often.
Is your family so type A that on the rare occasion that you actually need to crack the case on your machine, they can't wait half an hour for you to be done? Considering that they can still get to the internet the whole time. Now, if they can't get to the internet, yeah, you're fending off kids every 5 seconds. But if they can get to the internet,
Yeah, if YouTube and Netflix are still an option, I don't think you're going to be hassled for at least half an hour.
And frankly, even if they do, I'll tell them to pack sand and go watch Netflix or something until I'm done. The problem is when there's no internet access, you can't keep people off your back when they can't get to the internet. Short of like actual physical weaponry, it's not going to happen. But if they got the internet, you can just go pack them off to do something else.
But what if you absolutely have to take the internet down? What are the options then?
Send your kids outside to play and lock the doors.
Yeah.
I think the better thing here is, you can have, another copy of the hardware that your router runs on lying around so that it's very easy to restore your router's image to that backup hardware and drop it into place, which is frankly a great idea, especially the more people you have in your family. But I think even more importantly than that, because that is a pretty uncommon circumstance, and I find that family members are usually pretty understanding when it's like, look, the thing that gets us to the internet is hardware broken and I have to go buy a thing, they'll usually get off your back about that. However, it might be a really good idea to consider cellular broadband fallback for your router. That used to be expensive and difficult to manage. It really isn't anymore. If you want to go the FOSS route, you can build yourself a nice little OpenSense box on, a cheap old, laptop or desktop with 2 interfaces. And you can actually just attach a cheap cellular modem to it via USB. And, that shows up as a NIC, and you can configure it to fall back to that, cheap cellular plan when your ISP goes out. Personally, I have coax internet access in the Southeast where there's lots and lots of rain and lots of, airily hung cables that have tree limbs fall on them when the wind picks up. So the ISP dying happens a lot more frequently than my router dying. And I actually don't have it yet. I keep thinking I need to set that up. And now I'm telling all of you, you all need to set it up as well. If you don't go the OpenSense route, you can also buy a small FortiGate router. Those aren't particularly expensive. You can go more the small business route and grab a Cradle Point. Those are fully proprietary. They're easy to use. Some of them you can just stick a SIM card in directly. Some of them, you use, like I said, the simple little, not a hotspot, mind you, but just a simple USB cellular modem. just be careful that you practice that failover a few times so that you're certain that it will fail back once the main internet access is available again, because what you don't want to happen is to have your relatively inexpensive cell plan suddenly get all its data just absolutely consumed because your main ISP went down for an hour later it came back up and your router didn't notice, and so now you've been using your cell data for like a week wondering why things are slow until all your data's gone.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions or feedback. You can find me at joerest.com/mastodon.
You can find me at jrs-s.net/social.
And I'm at Alan Jude on all the good social networks.
And some of the bad ones. We'll see you next week.